The title of this paper is Quantum Mechanics. Hi friends, myself Dr. Jairamaya Jar, Assistant Professor of Physics, Government First Grade College, Tiptur. Today's session for BSc Physics 5th semester, and the today's session is de Broglie's wave equation. The objective of the sessions is to reveal the particle as a wave. The session outcomes is matter behaves as a wave. Matter behaves as a wave means how the particle are moving, it associated with a wave. So that is the meaning of how the matter behaves as a wave. We are going to discuss. So this is the session outcomes. Dual nature of matter. Previous session we are discuss the energy is a dual nature. Light is a form of energy. That light energy is a dual nature. One is wave nature and the other one is a particle nature. So today again, dual nature of a matter. The matter is a particle nature. How the particle nature behaves as a wave nature. So that is the meaning of a dual nature of a matter. Nature loves a symmetry. The energy exhibit a dual nature, and then matter also exhibit a dual nature. It means whenever the nature loves a symmetry, when the light energy of a wave exhibit a particle nature, it means the nature is clearly satisfies or clearly explain the particle nature of a matter exhibit a wave nature. So that means when the light energy has a dual nature, no doubt the matter is also a dual nature. So that is the concept of the nature loves a symmetry. Einstein established how the matter related with the energy and how energy related with the matter. So that is the Einstein mass energy relation, how energy is converted into matter and how matter is converted into energy. So that is Einstein mass energy relation. The relation we are going to like this. The relation is the Einstein mass energy relation is E is equal to m into c square, where E is the energy and m is the mass of the matter and c is the velocity of light. Next is expression for de Brogle wavelength. Expression for the de Brogle wavelength. So what is a de Brogle wavelength? The spirit of a de Brogle wavelength, how the matter is associated with the wave nature. So that is that de Brogle wavelength, how the matter or a particle is associated a wave. It means it associates a wave means it has a wavelength. So that is the concept of the de Brogle wavelength. Now we are look the expression for the de Brogle wavelength. Consider a particle of mass m or matter of mass m. That matter is moving with a certain velocity v. Then according to the Einstein mass energy relation, the energy of the particle is E is equal to mc square. Then according to the Planck's equation, the energy of the particle E is equal to h nu. Here E is equal to mc square is the mass of the energy of the particle is mc square and the energy of the particle E is equal to h nu. So these two equations are comparing E is equal to mc square and E is equal to h nu. These two energy are equating, then E is equal to h nu, where h is the Planck constant and nu is the frequency. Then E is equal to hc by lambda. Nu is nothing but c by lambda. That means mc square. This mc square is equal to h nu, where h nu is equal to hc by lambda. Mc square is equal to hc by lambda. Here c get cancelled. Then mc is equal to h by lambda. What is mc? Where m is the product of mass into velocity of light. It gives the momentum. The momentum p is equal to h by lambda. then lambda is equal to h by mc or lambda is equal to h by b. So this is the expression for de Broglie wavelength. So the wavelength is associated with the matter while moving with a velocity. Now c is the velocity of light. It compared with the velocity of the particle. Then since the particle moves with the velocity v, then de Broglie wavelength lambda is equal to h divided by m into v. So this is the de Broglie wave equation associated with the velocity v. If the same particle v having its kinetic energy, the de Broglie wavelength is associated with the kinetic energy of the particle, then de Broglie wavelength lambda is equal to h over me becomes lambda is equal to h divided by square root of 2me, where h is the Planck constant and E is the kinetic energy, m is the mass of the particle. So this is the de Broglie wavelength. Lambda is equal to h over me, where m is the mass of the particle, v is the velocity of the particle, h is the Planck constant. When this thing is associated with wavelength, this wavelength is nothing but a de Broglie wavelength. Similarly, the kinetic energy of the particle is associated with de Broglie wavelength. Lambda is equal to h divided by square root of 2me. So that is the concept. Some multiple choice questions are discussed on this session. The first multiple choice question is like this. The de Broglie wavelength of a particle, options are is proportional to mass, is proportional to impulse, is inversely proportional to impulse, does not depend on impulse. According to the classical theory, impulse is equal to force into time. According to Newton's law, force is equal to mass into acceleration. Acceleration is equal to rate of change of velocity. So then F into A is nothing but m into A by t, then into t get cancelled, then impulse is nothing but m into v is nothing but. So therefore, according to the de Broglie wavelength is lambda is equal to h over me. C is the correct answer. Is inversely proportional to impulse. Second question. If the kinetic energy of a free electron double its de Broglie wavelength changes by the factor. So the appropriate suitable answer relative relation is, in this question, lambda is equal to h divided by root of 2m into E. If E is the kinetic energy, if the kinetic energy is doubles, then we simplify this equation. So if E becomes 2E, then root 2 divided by 2. Root 2 divided by 2, that gives the correct option is C is the correct option. 0.707 is the factor for change in the de Broglie wavelength. Second question. When the velocity of an electron increases, its de Broglie wavelength. We know the relation lambda is equal to h divided by v. Lambda is equal to h divided by m into v. The relation here, the question is, when the velocity of electron increases, what happens to the de Broglie wavelength? The relation is lambda is inverse relation with the velocity. When wavelength increases, de Broglie wavelength, the options are increases, decreases, remains same, may increase or decrease. So therefore, the relation between de Broglie wavelength and velocity is inverse relation. Therefore, velocity increases, the de Broglie wavelength is decreases. So option B is the correct answer. Next question. The de Broglie wavelength associated with a bar of mass 150 gram traveling at 30 meter per second is. So this is a straight relation. Lambda is equal to h over me. M is given, velocity is given, calculate the de Broglie length. So that 150 gram is given in CGS unit. So now converted to SI unit in terms of kg, 150 into 10 to the power of minus 3 kg. The values are substituted. H value is a Planck constant is substituted 6.624 into 10 to the power of minus 34 joule second. So the values are substituted and simplify. We get the de Broglie value. That value is of about 1.47 into 10 to the power of minus 34 meter. So therefore option C is the correct answer for the questions. Some references are of this session. Kshamata Muktavat, A.K. Upadhyaya, Applied Physics, A.K. International Publishing House, Private Limited. Second book is R. Murugesan, K. Siva Prashant, Modern Physics, S. Chan and Company Limited. Thank you.